Good day everyone, welcome to BSABE-A Tutorials. In this video, we will solve again a fluid mechanics problem from the book of Yunus A. Sengel and John M. Simbala. Chapter 7, Dimensional Analysis and Similarity. Problem 7-37. So in this problem, a student team is to design a human-powered submarine for a design competition. The overall length of the prototype submarine is 4.85 meters, and its student designers hope that it can travel fully submerged through water at 0.440 meters per second. The water is fresh water, a lake, at temperature equal to 15 degrees Celsius. The design team builds a 1/5 scale model to test in their university's wind tunnel. So as you can see in the figure, a shield surrounds the drag balance strut so that the aerodynamic drag of the strut itself does not influence the measured drag. The air in the wind tunnel is at 25 degrees Celsius and at 1 standard atmospheric pressure. At what air speed do they need to run the wind tunnel in order to achieve similarity? So in this problem, we have the given temperature is equal to 15 degrees Celsius. The length is equal to 4.85 meter and the velocity is 0.440 meter per second. So for a scale model of submarine being tested in air, we are to calculate the wind tunnel speed required to achieve similarity with a prototype submarine that moves through water at a given speed. So our assumption in this problem is that compressibility of the air is assumed to be negligible, and the wind tunnel walls are far away enough so as to not interfere with the aerodynamic drag on the model. And the model is geometrically similar to the prototype. So we have the properties, which is for water at temperature 15 degrees Celsius, we have the density is equal to 999.1 kilogram per cubic meter, or that is 1000 kilogram per cubic meter, and the atmospheric pressure and the mu is equal to 1.138 times 10 raised to negative 3 kilogram per meter times second. For air at state, temperature is equal to 25 degrees Celsius and the atmospheric pressure is equal to the density 1.184 kilogram per cubic meter, and the mu is equal to 1.849 times 10 raised to negative 5 kilogram per meter times second. So in our analysis, the similarity is achieved when the Reynolds number of the model is equal to that of the prototype. So the similarity, Reynolds number, is equal to the density times velocity times the length divided by the mu. So we have, this is equal to the Reynolds number of equal to density times velocity times length over the mu p. So if we solve equation, this is our equation 1. If we solve equation 1 for the unknown wind tunnel speed, we have Vm is equal to Vp times mu m divided by mu p multiplied by density p divided by density m multiplied by the length p divided by the length m. we have, substituting all the values we get, we have 0.440 miles per second multiplied by 1.849 times 10 raised to negative 5 kilogram per mass per meter times second all over by 1.138 times 10 raised to negative 3 kilogram per meter times second multiplied by 999.1 kilogram per cubic meter all over by 1.184 kilogram per cubic meter multiplied by the length, which is 5. We get, solving this in our calculator, we get 30.2 miles per second. So this is our velocity. So this is our final answer. So that's it for today's video. Thanks for watching. See you again in our next one. Again, happy learning!